In our class, we have started technically a complex LR circuit. Remember, I am teaching parallel to your juniors also, laws of motion and all that. And all that are attached to YouTube also, so that it will be accessible for you also. So make use of those videos in case if you have sufficient time. Laws of motion, all the topics. Relative motion I have done. Laws of motion first week is happening right now. Okay. So my question here very simple. You can see this on the screen. It's a very simple question. In the circuit shown in the figure, the switch is closed since long time t is equal to 0. Okay. At t is equal to 0, you have opened. What happens? See, try to please understand in steady state. Okay. In steady state. What is that? I'll see that is an arrangement like this. Remember, in steady state, inductor behaves like a conductor. You know that. You are well aware of this situation. Right. Inductor behaves like a conductor. Right. A steady current will flow through because it is a 10 ohm and this is also 10 ohm. And obviously, a steady current of or 10 by 10, 1 amp will pass through this, 1 amp will pass through this in steady state. Now, immediately, what have you done? At t is equal to 0, switch is opened. Then immediately after this, what happens? Immediately after this, the current will be run by the inductor. The inductor acts as the source. R2, R1. So across inductance, what is the effective resistance? It is nothing but R1 plus R2, which is 10 ohm. What is the time constant of the circuit? L by R, 0.2 by 10. So 20 milliseconds. Right. Till this point, there is no issue at all. Now, what else you want here? Now, this current, it's a decay. We have done this yesterday. What is the expression for the decay current? E naught T by tau. I naught means at the instant, what is the current? 1 amp at T is equal to 0. So 1 into e to the power of minus T by tau. Find the current through R2 just before and just after the switch opened. It is 1 amp, obviously. What else you expect? It is 1 amp, obviously. So therefore, right, what do you want? Thereafter, find the time at which the current in R1 falls to half of its initial value. This is the first part of the question. At t is equal to 0, current through R2 is 1 amp. Okay, but remember, just before t less than 0, current is from A to B. Whereas just t is equal to 0, the current is from B to A. IR2 is 1 amp. And by the way, find the time at which the current R1 falls to half of its initial value. I is I naught by 2 is I naught e power minus t by tau. E power t by tau is 2. T is tau natural logarithm of 2. Tau is, just now we have done 20 into 10 to the power of minus 3 times natural logarithm of 2 is nearly 0.7. So I can say approximately, you can say it is a 20, right? Resistance. What is resistance, by the way? It is 20 ohm. 20 ohm. 10. 10. So nearly 70 microsecond. 70 microseconds, if I am not mistaken. Just please take the, okay, just please take this. I repeat, 0.2 by 20, 1 by 100, 0.01. So 0.01 can be written as 10 into 10 power minus 3. Nearly, this is 7 milliseconds actually. This is 7 milliseconds. Boys and girls, do you have any doubt in this question? Ask me right now. Anyone having doubt on this, ask me right now. Aditya, any doubt?
No, sir.
Mahant, any doubt?
Sir,
Sir, no, sir.
Sanjana, why you are not coming all these days? Any reason?
I had improvement exams, sir.
Right. Are you following videos?
Yes, sir.
Right.
sir,
Yes.
sir, the effective resistance is 5 now, sir. It's in parallel.
However, across this is the path. Series.
Okay,
The
that's
same
fine.
current that pass through R1 and R2. Effective resistance is R1 and R2. ఈ 2 points మధ్య పాత్ ఇదే కదా, స్ప్లిట్ అవ్వట్లేదుగా.
Yes, sir.
Right. So now let us move on to the next model. This is your next model. Right. Your time now. Everyone try to solve this. Everyone. Soumya, classes విన్నావా?
Yes, sir.
Right. Very good question, actually. If you are capable of doing this question implies, I believe that you have understood this topic. So, well, I'm just starting this question now. I've given you sufficient time. What is the first question? In the circuit shown in the figure, in steady state, inductor behaves as in steady state. Inductor behaves as a conductor. This part acts as a conductor. No, what? See, try to please understand. It's a simple circuit. This is E, and you have this is also E. This is a 0 volt. This is E volt. 2R. R. This is also 0 volt. My potential drop is E, and the current is E by R. And the current is E by 2R. And both the currents pass through the same 3E by 2R. Honestly, have you followed this? That's the first question which I would like to ask.
Yes, sir.
Akka, remember, if you fail in understanding this, you will fail almost all the options. Right. Next. Next question is
Sir.
yes.
Sir, if there is no potential difference, then how will the current 3E by 2R flow, sir? In that
1
condition?
minute. What is the question? In steady state is what you asked. In steady state, inductor behaves like a conductor. Any given instant, we will deal it later. What you said is at a given instant. So what to do? Replace the inductor with the conductor. That's what I have done. Next, what is the potential difference across the inductor? Technically, potential difference across the inductor at this stage. What is the potential difference across the inductor at that stage? Now you see the potential difference. No, see, remember at steady state they're asking. At steady state, potential difference is 0. That is the reason I have taken these two things. Otherwise, what we will do? A, B. Right. Now, at this situation, the moment when you close right, L to R, A, B. That's the deal. Hurry, hold on. I am assuming that the current through this is I1 and the current through this is I2. At an instant, current through this is I1 plus I2. Someone is asking me right now, what is the potential drop across AB? The potential drop across AB is nothing but d by dt of I1 plus I2. Clear. Now, one more important point. Now, one more important point is, remember, if you take this loop alone, we will call this as some delta V for a while. If you take this loop alone, minus E plus I1 R plus delta V is equal to 0. In this loop, let this be equation 1. How I got this? Tell me. Kirchhoff voltage law in loop 1. What is loop 1? This is loop 1. This is loop 2. Similarly, here also minus E plus I2R plus delta V is equal to 0. Equation 2, Kirchhoff voltage law in loop 2. We are applying at that instant particularly. Now, what is that we are going to have? Here, one thing is wrong in this. This is a 2R. Right. By the way, I1 plus I2, wherever I see, I'll write this as delta V, E minus delta V. E minus delta V by R plus E minus delta V by 2R. Right. Now, by the way, what do you want in this? Delta V, we know. Let this be some I. This I can be written as 3E by 2R minus 3 by 2R times delta V, L di by dt. Now you know how to handle this. How? Now I am writing this part here carefully. Now this part, we'll shift it to here. Right? We'll change the color. I'll just rearrange this properly. di by dt is di by dt is E minus 2 by 3 times IR. L somewhere. L is also there. di by dt is E by L. Right. LdA by dt. Or I can write it like this also, LdA by dt otherwise. LdI by dt. So therefore, di by E minus 2 by 3 IR is equal to dt by L. And do the integration properly. What are your limits? T is equal to 0. We know the current is 0. At some time t, let the current be I. Now this allows 1 minus 2 by 3 R log E minus 2 by 3 IR by E minus 0 is T by L. So now again, proper substitution, you will have 1 minus 2 by 3 IR by E is equal to, you will have minus 2 TR by 3L. Now I got the point. What is that? Rearranging this. 1 minus 2 by 3 I into R by E is e to the power of minus 2R by 3L times T. So I is 3E by 2R times 1 minus e to the power of that's the deal. That's the deal. I have given you the expression for I. Even I can give you the expression for di by dt also. 3e by 2r times 2r by 3l times e to the power of minus 2r by 3l times t. By the way, cancellations will affect, and here you will get e by l times 2rt by 3l. You know, at any time, the rate of change of current across the inductor is given by this expression. By the way, what is the question? Potential difference across the inductor is what you want. Okay, fine. I'll answer now everything. A. Potential difference across the inductor is LdI by dt, which is nothing but, yeah, what is that? E times e to the power of minus 2RT by 3L. Next, what do you want next? Rate of change of current through the inductor coil. Already that is also given. Di by dt is E by L e to the power of minus 2RT by 3L. Third question, potential difference across the resistance. Which resistance you did not mention? Even then I can give. Hello, even then I can give. How I will explain? Now you take equation 1. From equation 1, you can write I1 as E minus potential drop across the inductor by resistance. So therefore, E by R minus VL is E. E by R times e to the power of minus 2R3 by TL. Similarly, I can write I2. I2 place in the place of R, I will write simply 2R, which means E by 2R minus E by 2R times 2RT by 3L. Boys, any doubt? Very good question, actually, according to me. A very good question. High in depth in concepts. మహంత్ నిన్న ఎవడు రాలేదురా వాడు. ఇవాళ ఈ క్లాస్ వింటే వాడికి ఏమైనా అర్థమవుతుందా? మహంత్. అదే కదా నేను చెప్పేది. ఇప్పుడు ఇంటర్మీడియట్ చదివినట్టు చదివితే ఎక్కడ వస్తాయి? ఐఐటి కానీ ఎంట్రన్స్ ఎగ్జామ్స్ కానీ ఎక్కడ వస్తాయి? ఆదిత్య మొత్తం ఫాలో అయినట్టేనా?
Yes, sir.
ఎక్కడా కాంప్రమైజ్ అవటం లేదుగా?
No, sir.
రైట్. ఒరే ఇప్పుడు నేను రాయబోయే క్వశ్చన్ పాత్ ఫైండర్ క్వశ్చన్ కూడా సూపర్ క్వశ్చన్. ఇది మీరు చేయగలిగితే ఇదే క్వశ్చన్ పాత్ ఫైండర్ ఎలా ఎడుగుతారో కూడా నేను అది కూడా పెడతాను ఒకసారి. సేమ్ క్వశ్చన్ ఇన్ పాత్ ఫైండర్. You have a same question in Pathfinder also. It is all yours. Try this. Both questions are same actually. మరి ఇవాళ కుదిరితే ఈవినింగ్ కూడా నేను క్లాస్ చెప్తాను రా, కొంచెం అవైలబుల్గా ఉండండి. In the circuit shown in the figure at steady state, all the resistances are same. You know what is happening at steady state? At steady state, you know what is happening? A current of 3I is entering. It follows I. Follows I. Follows I. Remember, the current through this inductor is 2I and the current through this inductor is I. L, 2L makes no difference. Same thing here also. Right. In the places of resistance, you have bulbs. Right. అరే నేను అడిగే క్వశ్చన్ ఇప్పుడు చెప్పేవాడు ఎవడైతే ఉంటాడో ఈజ్ హోల్డింగ్ పర్ఫెక్ట్ సబ్జెక్ట్. ఆదిత్య, ఇఫ్ ఐ ఓపెన్ స్విచ్, కెన్ యూ ప్లీజ్ టెల్ మీ వాట్ ఈస్ గోయింగ్ టు హ్యాపెన్ టు ద సర్క్యూట్? If I open switch, what is going to happen? Can you please tell me? Open the switch.
అప్పుడు ఇండక్టర్ సోర్స్ లా యాక్ట్ అవుతుంది.
అదే కరెక్ట్గా చెప్పావు, పర్ఫెక్ట్గా చెప్పావు. ఇప్పుడు రెసిస్టెన్స్లో వాట్ ఆర్ ది కరెంట్స్ అక్రాస్? ఫర్ ఎగ్జాంపుల్, దిస్ ఇస్ A, this is B, and this is a C. Earlier, all the resistors carry the same currents. Now what happens? That's my point. Remember, this carries a current of 2I still immediately after closing. Immediately after closing, it carries a current I. The issue is, boys and girls, due to this 2I in this direction, due to this I in the upward direction, what is going to be the net current through B? What is going to be the net current through B, boys and girls? That's the answer. Here, I'm not asking a really difficult question. Aditya, what is going to be the net current through B at that instant? Immediately after opening key, I through this, 2I through this, I through this. Now tell me, what are your answers? Immediately after this, what happens? Mahant. ఏమవుతుంది? మరి అంతా నేను రాసేసా కదా అక్కడికి, మీరు చెప్పేదే ఉందా? Darshan, what happens to the current through B immediately after closing, after opening? What is going to be the current through B immediately after opening the key? No one is answering. No one.
Sir, brightness of the bulb increases.
No. Through A, it is going to be 2I. Earlier, through A, the current is I.
I.
Through B, current
Yes,
is
sir.
I.
Option
Through
A.
C, current is I. Whereas now through current A is current 2I. Through B, current is I. Through C, current is I. No change in B and C, but there is a
Yes, sir. That is option
change
A.
in A. So therefore, brightness of A suddenly increases, but that of B and C remains unchanged. That's the answer for this. You need to know what is happening after this. Palvita, have you understood the concept?
Yes, sir.
నిన్న నువ్వు క్లాసులో ఈ టాపిక్ ఏమవుతుంది ఇమీడియట్లీ ఆఫ్టర్ డిశ్చార్జ్ వినకపోతే ఈ క్వశ్చన్ చేయగలుగుతావా? ఎస్ ఆర్ నో? పల్విత,
No, sir.
రోజు క్లాసెస్ రమ్మనేది అందుకే కదా. 26 మెంబర్స్ ఉన్నారు. మిగతా వాళ్ళందరికీ ఏం అర్థం అవుతుంది నాకు చెప్పండి ఒకసారి. వీడియో చూస్తే అర్థమైపోతుందా? డౌట్ కూడా అడిగే అవకాశం ఉండదు కదా యూట్యూబ్లో. నెక్స్ట్, మే క్లోజ్ దిస్ క్వశ్చన్ ఆర్ యూ స్టిల్ హ్యావ్ ఎనీ డౌట్ ఆన్ దిస్, బాయ్స్ అండ్ గర్ల్స్? ఆదిత్య, మే క్లోజ్ దిస్?
Yes, sir.
Right. We move on to the next question. It's a very, 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 very good question. Try to work on this immediately. An inductor in a sliding wire generator. Here 1 and 2 are two perfectly conducting parallel rails. So there is a separation L, a pure inductor L
Sir.
is used to connect.
Sir.
Yeah, yes.
Is the answer in terms of sign?
Honestly, this will execute SHM actually. Now, what is your answer? Tell me. I'll say yes or no for that.
Sir, V naught root ML by BL into sine.
Remember, when you are answering
Sine of
anything,
BL.
all these things must be in the terminology of the given data. Remember, tomorrow's class is very important. Tomorrow's class, it is on mutual inductance. Very, very important area. So therefore, no one miss tomorrow's class. Right. Your final answer in this question is X is V naught by omega sin omega t. Aditya, you got the same?
I'm trying, sir. I didn't get it.
No issues. I'll do it. Now see, forget about an inductor here. Forget about inductor.
So
Yes. Chupnana.
I got the same, but it is in the terms of BL and
Yes. Oh, omega term convert cheskali. Right. Good. Mahant. Keep it up. Now see, forget about while about the inductor. Otherwise, this is all known to us. Our last week topic only. This is moving with velocity V naught. Mahant, మీ గ్రూప్లో లాస్ట్ వీక్ అడ్వాన్స్డ్ పేపర్ పెట్టిన వీడియో పెట్టారా మీకు మీ గ్రూప్లో వచ్చిందా?
సార్ అది మొన్న రాసిన అడ్వాన్స్ లేకపోతే
ఎస్, మన రాసిన అడ్వాన్స్ వీడియో రికార్డింగ్ పెట్టారా? యూట్యూబ్ లింక్ పెట్టుంటారు మీకు ఏదో.
పెట్టారు.
బట్ మీరు చూడకండి, జస్ట్ మీ పేరెంట్స్ చూడమని చెప్పండి అంతే. ఇప్పుడు అక్రాస్ ఇండియా అరే inward magnetic field, direction of motion, right words. Fleming's right hand rule we will need to use. I'm using Fleming's right hand rule. Inward, direction of thumb leftward, rightwards, central finger upwards, which clearly implies in the process minus and plus. And therefore, across inductor, you will face the same situation. Across the inductor, you will face the same situation. Right. At any instant, L di by dt is BVL. L di is BL V dt. Do the integration. T is equal to, we will take this as the point of projection as x is equal to 0. The instant when you projected this, we will take it as x is equal to 0. Right. Now, in this case, at t is equal to x is equal to 0, you have velocity actually. Right. L I is equal to Bx. Vdt is x L. Right. One more important point is, now I got very clearly about this relation. Right. This is the first equation. And one more important point that you can quote it from here is, what do you want? Don't forget. What exactly you want? Meanwhile, you study the rod. Rod at an instant is moving with a velocity v like this, displaced by some distance x. And what is the direction of the current? This is the direction of the current, I. Fleming's left-hand rule. Inward, so it experience a restoring force F like this. Fb is BIL, which is nothing but minus M dV by dt. Hold on. So I got an expression for I from equation 1. Let this be equation 2. 2 and 1 implies dV by dt plus L by M I is equal to 0. dV by dt plus I represents BL by L, x is equal to 0. Here, this is nothing but d square x by dt square plus bl square by ml x is equal to 0. It is SHM. This is the condition for harmonic oscillator. And here projecting from x is equal to 0, x is a sine omega t. That is the format where omega is under root b square L square by ml. Sir, you may ask me, how do I know A? What is V naught? At the equilibrium, its velocities. This is x is equal to 0. So maximum velocity expression, omega A. So therefore, A can be written as V naught by omega sin omega t. Any doubt? Ask me right now, boys and girls. If you have any doubt, ask me right now. Are you compromising? Check all the time. Palvita, have you followed?
Yes, sir.
Sahasra, have you followed? Right.
Yes, sir.
వీడు కనిపించట్లేదు నాకు. గౌరవ్ రాలేదు ఇవాళ. గీతిక ఫాలో అయినట్టేనా?
Yes, sir.
Right. Let's move on to the next question. It's an excellent question actually. Once upon a time, this is IIT advanced question. At that time, it is not advanced, subjective. IIT subjective type question. Now, all is yours. Try this. Remember, I told you very clearly, this is once upon a time a very good question. Now we'll do one by one, step by step. Right. Metal bar AB can slide on two perfectly conducting parallel rails separated by a distance L. Here, L it is. Resistance R and inductance L are connected to the rails as shown. A long straight wire carrying a current I0 is placed in the plane of the rails and is perpendicular to them. The bar AB is held at a distance x0 from the long wire. At t is equal to 0, it is made to slide on the rails away from the wire. Now we need to calculate the flux. The first question is the same. Flux. If phi is the flux linked with the loop, first let me determine that. We know how to find d phi. D phi is simply B at that point L dx, which is nothing but mu naught by 2 pi. AB is held at a distance L naught actually, right? First of all, what is that they are asking? Hold on. They haven't given any distance here. And they haven't given any distance here. So, they are not asking any flux. Any flux. Let me just focus. What I can do is d phi by dt I can do. So whatever the EMF induced here, that is dropped as IR plus. Why I have changed, why I have done U-turn? Because you haven't given me any data here in between. Right. From this, I can write d phi as IR dt plus LDA. You told one point. It is observed At t is equal to 0, there is no current. At some time t, let there be some current. And the change in flux delta phi is R times IDT plus L times dI. So the change in flux delta phi is R times the charge passed through delta Q and Li1. So what you want? Delta Q. T is equal to 0 to T is equal to capital T. This is nothing but delta phi by R minus Li1 by R. Very famous. The bar AB is at a distance x0 from the long wire. T is equal to 0, it made it move, right? It is observed that at time T is equal to T, the bar AB is at a distance of 2x0. Now the question is, sir, how do I know the change in flux? Now I will come back. I was just trying to do the same previously. Mu naught by 2 pi I by I naught by x L dx. Now you apply the limits. So the change in flux is mu naught by 2 pi I naught L. Okay. What do you have? Integration limits is from x naught to 2x, which is natural logarithm of 2. This I have. Let this be equation 2. Let this be equation 1. Now what do you want? Use the content of equation 2 in equation 1. So delta Q is finally mu naught I naught L by 2 pi R times natural logarithm of 2 minus Li1 by R. Any doubts? Next. What is the time constant of the circuit? This is a conducting rod. There is no resistance. So the time constant of the circuit is simply tau is L by R is the time constant of the circuit. Right. What do you want? The bar is suddenly stopped at time t. The current through the resistance R is found to be I1 by 4 at time 2t. Find the value of L by R in terms of other quantities. Now you said you stopped at time t is equal to g. Please consider seriously this question. Boys, this is the resistance part. This is the inductance part. Now t is equal to tau, t is equal to t is our new time. T dash is equal to 0. At that time, the current is I1. You clearly mentioned that. I1. You just mentioned now. Here you have mentioned that. Now it is a decay circuit. I is I1 e to the power of minus t by t dash by tau. What do you want? You said yet t is equal to 2t, or in my language, t dash is equal to t. T dash is equal to t. Current is, you said I1 by 4. Here you mentioned that. So I1 by 4 is I1 times t by tau, which means e to the power of t by tau is 4. So T is tau times log E4. What do you want? L by R term. T is L by R times log E4. So finally, what you have? L by R term is nothing but T by natural logarithm of E4. Remember that time questions of this level of difficulty, they use it as only 5 or 6. What is the time? What is the time? Cut 10 minutes, wait so much. Class లో. Right. Right. ఒకసారి ఆంజనేయులు సార్ ఉన్నారేమో చూడు పిలుచుకుంటారు ఒకసారి. Right. Boys, any doubt on this? You can ask me. This is once upon a time a difficult question. A lot of students troubled, but issue is half the question can be done. I'm still asking you. Aditya, any doubt?
No, sir, no doubt.
Pakka.
Yes, sir.
Right. Palvita,
Yes, sir.
any doubt?
No, sir.
Geetika.
No, sir.
Right. Yes. Everyone start working on this question. Right. You please try this. Anyone? See, in figure, the lamp P is in series with an inductor and two different experimental observations are recorded with an air core inductor and then with an iron core inserted inside the same inductor when the switch S is closed. See, try to please understand what is the effect. L, inductor is proportional to square of number of turns and relative permeability. So L2 L2 obviously be greater than L1. Why? Because you said iron, mu r is high. One more important point, time constant. T1 is L by R. T2 is L2 by R. Clearly, tau 2 is greater than tau 1. So, what is the role of the inductor? I'll explain. See, try to please understand. You are seeing one graph like this. Right. So, in this graph, I am plotting a graph taking, this is for current versus time graph. You know, at one time constant, say tau, you will get one time constant, you will get nearly 0.63 percentage. Yesterday I told you this 0.63 times I naught at one time constant. But what if these are two different time constant? One is a tau 1 and the other is that's how you will have. No, the other time constant is somewhere over here. But tau 2 is greater than tau 1. This is for L2 and this is for L1. Now back to question number 13. The rise of current is slower if the inductor has an iron core. Sure, because 0.63 I naught, it has reached quickly with air, but it took some delay in case of iron core. So option A is absolutely correct. So when A is correct, B is wrong. The time constant is higher if the inductor has an iron core, right? Because L2 is greater than L1 and this. మీరు అట్లీస్ట్ సి ఆప్షన్ అన్న పెట్టగలిగే స్టేజ్ ఉండాలి మీకు అట్లీస్ట్. Now I'm asking you, have you followed this question? Yes or no? Geetika, have you understood this question?
Yes, sir.
Right. సౌమ్య ఏమైనా ఫాలో అవుతున్నావా? నువ్వేం క్లాసులు వినలేదుగా, పాత క్లాసులు లాస్ట్ 2 classes వినలేదా నువ్వు? Next, a similar question you have. Right. Try to answer this. Everyone try to answer this. I have planned a lot of questions today. 1 minute. 1 minute. 1, 2, 3, 4, 5. A lot of questions were there. I might take one more class today. I need to finish these questions by hook or crook. The recording is not possible at that length. Very difficult for you to access thereafter. I should give break. Yeah, tell me, when the switch S in the shown figure is closed, a current flows in the solenoid. You can see that the current flows like this. Like this. So if I observe from this end, I'll see that here I will have a north pole and this end behaves as a south pole because of the direction of flow of current. You may ask me how. Use right hand grip rule. The 4 fingers of the right hand turn around the cylinder, thumb is leftwards. Right. Now, and it is growing. South is growing. So, you see, it has to happen as if it should be repelled. Repelled means you should see a south pole here. So now tell me what is the direction. So if I am observing from here, if I am an observer here, an observer here will see south. South means clockwise. Clockwise. Just after the switch is closed, you will see a clockwise. Actually, the ring will fly off also. It moves away. Suddenly, it moves away. Okay, just after closing. And long time after the switch is closed, anyone in the class? Long time after closing the switch. Anytime, month. Aditya. Long time after the switch is closed, do you see any current flow? Aditya.
Yes, sir.
Current
No
flow in
increase
ring.
current ఉంటుంది, sir.
Aditya, current flow in ring untunda?
No, sir.
Right. Why? Because steady flux. No current flows. Because steady current flows in solenoid. Next. After opening the switch, what happens? It attracts. Actually, it happens to be, it should be attracted. See, exactly reverse to the previous case. Flux decreases kada. So in Nilo there is no change. It's south, but decreasing. So therefore, in that case, it will induce a north pole, which means just after opening, you will see an anti-clockwise current. But only during closing, only ring will be pushed away. Clockwise. So till here, any doubt? Boys and girls? Any doubt? No one is responding actually.
No, sir, no doubts.
Right, thank you.
Sir, once can you show the upper question?
Yes, Mahan.
Sir, 1 minute.
I'll post the notes. If you have doubt, ask her.
Yes, sir, you can scroll down.
Yeah. Yes, it's all yours. With this, I'll close this session and afternoon, if possible, I'll take after 3 o'clock. Because Mahant, what is your max class timings? Any date? Any idea?
Sir, 130 to 330.
Right. I'll try to take some time between 345 to 445. In the circuit shown in the figure, E is equal to 120 volts. Some numbers were given. Switch is closed at T is equal to 0. Just after the switch is closed, T is equal to 0. At T is equal to 0, inductor behaves as open circuit. So what is the potential difference across R1? Clearly 120 volts. What is the potential difference? Now, what is happening? I'll just explain. At that instant, no change in R1. This point behaves like an open circuit. C D R2. And no current through this. So the potential drop across R1 is VA minus VB is 120 volt. Right. And the potential drop across inductor is also 120 volts. I'm assuming it's an ideal cell. Right. VC minus VD is equal to 120 volts. Obviously, VC is greater than VD. Next. What is the potential? I have done all. I've done all. Right. Just after the switch is closed, I have done. Which point A or B is a higher potential? Obviously, A. Right. What is the potential difference across CD? What I have done all in one shot. If your question is just after the switch is closed, I have done all. If you still have doubt, question me. All yours. Question me if you have any doubts. Boys and girls, you still have any doubt? Question.
Sir, once can you again explain the circuit?
Simple. Very simple. See, you want just after the switch is closed. Immediately after the closing the switch, inductor behaves as open circuit. When will inductor behave like conductor? Steady state. Similarly, capacitor initially behaves like a conductor. Long time after closing switch, it behaves like open circuit for capacitor. Whereas inductor reverse. This is the circuit actually. So the entire current will pass through in this way. So therefore, I1 is nothing but 120 by 30. Right. Switch is closed at T is equal to 0. Just after the switch is closed. This is there is no current through this part. At T is equal to 0. The current will flow through this. Got the point? Right. Arya, someone was asking this question. Any doubts? అరే ఇప్పుడు దీనిలో కరెంట్ పోకపోతే ఈ పొటెన్షియల్ సేమ్, డి పొటెన్షియల్ నెగటివ్ పొటెన్షియల్ ఆఫ్ ద బ్యాటరీ సేమ్, విసి మైనస్ వీడి అదే అవుతుంది కదా.
Yes.
రైట్. ఇక్కడ క్వశ్చన్ అడిగే విధానంలో చిన్న మిస్టేక్. స్విచ్ ఓపెన్ చేస్తే ఏమవుతుంది అంటే దట్స్ ఎంటైర్ డిఫరెంట్ థింగ్ అగైన్. స్విచ్ అక్కడ ఎక్కడైనా ఓపెన్ ప్రస్థానం చేశాడా? ఫస్ట్ 2 points క్లోజ్డ్. వాట్ ఈస్ ద పొటెన్షియల్ డిఫరెన్స్ VSD అక్రాస్ ద ఇండక్టర్ జస్ట్ ఆఫ్టర్ స్విచ్ ఈజ్ ఓపెన్? ఇప్పుడు క్లోజ్డే కదా మనం డిస్కస్ చేసింది ఇనీషియల్గా. ఇప్పుడు ఓపెన్ డిస్కస్ చేద్దాం. ఓపెన్ డిస్కస్ చేసే ముందు స్టడీ కంపల్సరీగా చేయాల్సిందేంటి? at steady state. You know what is happening at steady state? At steady state, 30 ohm, and the current that passes through this is 120 by 34 amps. Whereas in this, inductor behaves like a conductor. For only purpose of identity, I am drawing inductor. Otherwise, the steady current will go through this 50 ohms, and current will be 120 by 50, 240 by 100, 2.4 amps. This is the steady current conditions. Now, please tell me at steady state, have you all followed Pakka inductor? Boys, please. Have you
Yes.
followed the steady state condition? Immediately after opening the switch, you know what is going to the circuit? R1. Now, inductor drives this current. 2.4 amps. Immediately after opening the key. This is 50 ohms. This is 30 ohms. Now A and B. I can write VB minus VA like this. 2.4 into 30 plus 2.4 into 50. So this is 24 threes, 72, and 24 fives, 120. And this is nothing but 192 volt. Which is more dangerous, switch off or switch on? You will see the potential drop is high. Bulbs ఎప్పుడు పోతాయంటే స్విచ్ ఆన్ చేసినప్పుడు కాకుండా స్విచ్ ఆఫ్ చేసినప్పుడు పోతాయంటానికి this is indication. You see the drop across that. It's higher than 120 volts. So therefore, the danger is left during the opening of the key, not closing of the key. Now I am asking you, do you have any doubt on this part of the question? Ask me comfortably. Boys. Aditya, any doubts?
No, sir.
Right. Darshan, do you have any doubt? Darshan. Geetika, any doubt? Geetika.
No, sir. No, sir.
Right. So we will meet again after 3:45. Right.